Hello and good morning, everyone. This is Danielle Benton, and this short presentation is going to revolve around the Walt Disney Company and their revenues over the last decade. I'm going to go ahead and begin here with the setting of this situation. The executives at Disney have decided to renovate a section of the park. It's going to require them to temporarily close some of the popular attractions for a few months. Ultimately, as we see here in the last bullet point, the goal of this analysis is to determine the ideal time to close the park so that they incur the smallest loss in revenue. So we're going to go ahead and start our time series analysis. I can actually let you take a look at my Excel spreadsheet. All this data here we're going to go through briefly in this presentation, so don't worry about that. We're going to start here with the first step, which is a regression model to determine the predicted revenues. My regression model yielded a 0.95 adjusted R-squared value, which is absolutely wonderful. And that has led to some values here that are very close, however not identical, which means that we do have some inaccuracy in my data and equation here down at the left-hand corner. So we need to go ahead and test for some inaccuracy. I've picked out three different methods: the mean absolute percentage error, the mean absolute error, and the average of the sum of squared forecast errors. I'd like to point out that this here is a 3.05% error, which is good, but I think we can probably do a little bit better. So we're going to go ahead and move on to our second analysis, which is our seasonal forecast. In our seasonal forecast, we can see that our percent error has gone down dramatically to a 0.197%. In the screenshot, you can see that they're very close in all the cells for the dates. I think that this is an absolutely wonderful percentage, but I think we're going to move on to some more complicated analysis, beginning with the 6-month moving average. The 6-month moving average, you can see there the definition of this method. However, we do have a average percent error of 2%, which is not quite the same as that 0.197 we saw in the seasonal forecasting. So it's a little bit disappointing there. However, we are going to try one more time series analysis, which is the exponential smoothing method. This method, a little bit more complicated, but almost always a very good measure of predicted values. In this case, we did end up with a 10% percent error, which is very bad. We do not like that. However, we're not going to disregard this information. We're going to go ahead and compile this data and compare it to the others. I do have here in the next slide a nice visual. I think the first thing you may notice is that there's no seasonality in this graph. It's kind of more linear, actually, except for this little point right here. So that's very interesting. And that may have caused some of our errors in the analysis. However, this is quite a good graph. Everything's kind of close together, which is always nice as well. So I'm going to go ahead and start wrapping up here with my conclusion. I do want to mention a few failed techniques that I tried, including a 1-year moving average and a weighted moving average, both of which yielded higher percentage errors than the other 4 methods I tried earlier in the presentation. On the bright side, I'd like to highlight some of the successes of this analysis, including the clear correlation between the independent and dependent variables. We have some great accuracy, especially with the seasonal forecasting. And while exponential smoothing and 6-month average are often more accurate in seasonality time series evaluations, the simple linear regression and seasonal forecasting were the most accurate in this situation. So just want to make a few future predictions, about 48 to 49 billion for the rest of the year here. And so to conclude, we'll move back to the executives. I highly recommend that Walt Disney look at some other data to determine when they're going to close the park, maybe occupancy levels and weather. I think those may yield more accurate results. And I just want to say I was surprised by the data, but this analysis was absolutely wonderful, and thank you so much for listening.